Hello, this is Jette Wagen, and this is the third screencast in a series of screencasts in which I will be introducing relational databases in Microsoft Access 2016. And in this third screencast, I will be dealing with writing queries. Now that you have a basic understanding from the first two screencasts about how to access your data, how to sort and organize your data, how to create tables and establish relationships. You have a basic idea about data design and database organization. And if you have all that in order for your project, then you can use queries to select records, add records, delete records, create subsets of data, but also make calculations with data in your tables, etc., etc. So the real power of databases is, of course, in the queries and what they can do for you to support your research and help you answer questions that you want to ask to your data. Now, to be a bit more technical about queries, what you actually will be learning in this screencast is how to use SQL. And SQL is structured query language, and this is the language that is used by, let's say, still the majority of the database systems that exist out there. You also have NoSQL systems, and of course you have object-oriented database modeling and such. But still, the largest part of the databases in use are SQL databases. So understanding this language is fundamental for relational databases. And what Access has done is it has created a graphical interface. So we're not going to write any SQL syntax, but we will just use the graphical interface of Microsoft Access to use the SQL language. Okay, so let's get into the actual course material. Now, I will demonstrate the use of queries with another training database, which is, and I'll show you, I've already opened it, of course. But I have on my desktop, I have the HALOS 2012 training database 1, and now I will use the training database 2, which is actually completely similar, but the results table actually contains real data that has been collected in the field and a whole bunch of records that have now been already filled with data. Okay, so in order to start designing a query, we will go to the Create tab in the ribbon of the program. And here we see in this third box, we see Query Wizard and Query Design. And I like to work straightforwardly in the query design environment. Now, if we click on that, we see that a window opens. It tells us Query 1, and we are confronted with this little window that we can use to add tables to our query environment. So let's say that I want to make a first query based on the table tracts. So I can double click on that and I can click close. Okay, what we can see now, and I will maximize this view, is that here we have the query environment that actually consists of two areas. So here in the upper part we have an area in which the tables that we use will be shown, and if I would add more tables they would be visible here, and relationships between them would be visible here, and I could change the relationships if I want. And in the lower part of the screen you have the actual graphical user interface for the query design. Okay, so let's start by creating a simple select query, which is the simplest query you can make. And I want to make a query from a selection from the tracts table, and I want to do that based on two criteria. So I want all the tracts that have been recorded by the person with the initials AK, and I want to select all the tracts that have been examined in the location of the Limni-Kiriou. And just to refresh our memory, we can see that here recorded by, we indeed have these initials. And then we have here in location, we have two locations actually as values, and we only want to select the records that have been recorded by AK in the Limnikirju location. Okay, then we have some further wishes. We want to see all the records that meet those criteria, which is technically called the query record set. We want them ordered by date, and we do not want to see the tracked ID and nodes field. So referring back to the first screencast, you can see that we can do in this query a whole series of data organization and selection actions at once. Okay, so let's start with the query design. Now, to add a field to the query design raster, double click that field in the table. And we want to do this now with recorded by, track number, location of course, and we want date and sample type. So remember, we did not want to see the nodes in this in our eventual record set. So now we may use this query simply to select a number of columns that we want to view. So if I would now go, and again, you can here switch from a design view to an actual datasheet view. We can at any time by hitting the view button on the left upper part in the ribbon, we can see dynamically the result of the query we have been constructing so far. And this is very useful because you can use this button every time to see if the criteria that you entered or the actions that you performed, that they actually give you the result that you want and that everything is behaving as expected. Okay, so let's start by adding the selection criteria. So we said we want to select all records that have been recorded by the person with the initials AK. So I will go to the criteria field over here and I will enter AK as a criterion into this field, and you can see that I don't have to indicate its text. It's being recognized as text and therefore it's placed between double quotes. Now, as I said, we can check the results, so let's do that. I will click view, and indeed we can see that we now have a subselection of all the data with only the columns that we selected and only the records for the person with the initials AK. So now we can enter our second criterion, and that would be Limnikirju location. Let's check it again, and indeed now we only have records that satisfy both these criteria, so recorded by and location. Okay, now finally we said that we wanted to sort the record set on date. So here we have sort as a separate field that we can manipulate. So if I click here in the design raster on the sorting options for the column date, I can select here ascending and descending. And if I click ascending, then we will have the data set as we defined it beforehand. So let's check it out. And indeed, we can see here that we now have the record set with the person with the initials AK, location Limnikirju, and indeed an ascending sorting on the date values. Okay, so it's very easy to change a query. So evidently you can add and remove criteria, but you can also simply add fields to the query. So again, you could just double click and it will be added to our design raster. And the other way around, if you select a column like this and I hit delete on my keyboard, then that field is then deselected from the query. Now we can also change their order, so I could for example say that I want to see the sample type before the date, and I can also make sure that the field is included in the query definition but is not shown in the result. So I can for example click on this tick box here, and so it's not shown this result, but the criterion is still used in the selection. So let's see what the result is now. I click on view. Well, as we just designed this to be, so sample type, the column sample type is now situated before date. We don't see anymore the recorded by field, but we see that the selection on the person with the initials AK is still functioning. So these are some very easy and simple ways you can change the query and the design of the outcome in a simple way. Now, if we are satisfied, we can also, of course, save this query. So if we would go to File and go to Save As, we can, as we've shown earlier, save this object as a query. And let's say we want to make this, we'll give this a name that is somehow easy to understand. So it's tracks by AK in the location Limni Kiryu, and then I will just use this as the name for the query and click OK. If we then would filter the contents of the contents of this table of contents by queries, we can see that we now saved this query. It is important to point out that you only save the definition of the query. If you click on the query, you will see the results, and these results will be dynamically updated by all changes to the table. So the query itself does not contain data, it just contains the syntax actually of the selection and all the manipulations that you do with that query. The data is drawn dynamically from the table, and if I would have entered in the meantime 3 or 4 more records recorded by this person of the location Limni Kiryu, then they would show up now in the resulting record set of this query. Okay, so let's make things a little bit more complex now. What I would like to do is to show you how you can query more than one table. So if I go to this query again, and I will change into the design view, I want to actually add the results table to this this query design. So let's add the results table. I can just simply drag and drop it from the table of contents. Here it is, and as I mentioned earlier, as you can see, the relationship between these two tables defined in the relationship design window can be used for all queries and is automatically opened and respected for this query. Another thing which is important here to point out is that an extra field has been added to our query design raster. So we now have here the option table that shows actually from which table these fields have been collected. So you can easily see from which table what fields are incorporated in the query. Okay, so let's now design a query based on this these two tables and their relationship. And I just will delete all fields from this this query. And let's say I want to have an overview for some reason of all the tracks that the person with in which the person with the initials NP collected materials and what did he or she collect. So I'm now talking to the actual field walkers and not the recording persons in our tracks table. So how do we go about this? I can add the double click on initials, clicks and finds, and then I want to see the related track numbers, location and date, and I want to see it, all the records that have been, or all the records in which results have been collected by the person with the initials MP. And you can see that Access automatically recognizes some letter combination, character combinations as codes that it will automatically complete because he recognized them as often used functions, but we don't want this, so we explicitly now enter the double quotes ourselves so we can ignore this function that is automatically suggested. And if I then hit the View button, you can see that indeed I now have all the records from the results table that have a person, the field worker with the initials NP. I have the related data from the results table, and then I have all the information that I wanted to see from the tracked table as well. So as you can see, it's quite easy to create a query over two tables. Now there are 2 points that I want to emphasize here. First of all, I realized that we didn't incorporate the actual fields defining the relationship between these two tables. So we didn't incorporate the primary key of tracked. We didn't incorporate the foreign key stored in the results table. This information and this relationship is automatically considered by ACASA, and the results are based on that relationship. So you do not need to incorporate those actual fields. So that's one. A second thing is that what we now have in this result, and apparently this person walked multiple lines for some fields, so he or she actually collected quite some material in one and the same tract. So what you see here is actually what we've been talking about in the second screencast, some level of redundancy because the information from the tracked table is repeated in this record set, and that was exactly what we tried to avoid in our table creation, because if we would combine these tables and simply make a single table from tracks and results, this is exactly the most likely solution we would come up with. Now, this is not a good way to work with it in a single table, because you would repeat every time the same information with all the problems that I mentioned in the second screencast. However, in this case, it's no problem, of course, because this data is dynamically drawn from the tables and it's only displayed as a result of this query. So this data is not stored more than one time, and that's exactly the where the normalization concepts of a relational database is about, to reduce the storage, the redundant storage of information and redundant entry of information. But of course, you can in overviews created such as this record set from a query, there's no problem in this repetition. Okay, so let's now make things a little bit more complex. Let's say that we want to be able to compare our tracts, and so we want to have a query that gives an overview of all tracts in our database and the total number of clicks per tract, if any. Okay, so in order to make this new record set, we again remove all the fields from our query, and we will add from tracts, we will add the recorded by, the tract number, and just for demonstration I will show you that you can also just drag and drop from the table to the design raster. I want to add location and I want to add sample type, and from the results table I want to add the clicks because I want to see the total clicks per record. Now there's one more criteria that I want to insert here, so I want to only just see the sample type transact entries, and well, let's inspect the results. Now what we now have is a selection of 44 records. Now, as to the result of this query, it's important to point out two things. So first of all, the records in the tracts table that have no corresponding records in the results table are not shown. So to demonstrate what I mean, as you may remember, I have in my tracts table tract ID 1 to 20, which are indeed tracts number 1 to 20. And in our results table, if we look at the foreign key here, tract ID, we can see that we only have results in this table for tracts 1 to 10. So maybe the results table is not complete, or there have been for some reason no finds or no entries in this table. But in any case, I only have information related to the track numbers 1 to 10. And this is reflected in our query result because we have only here the track numbers 2 to 10, and we do not have any information on the other tracks, whereas we still wanted to incorporate them because we wanted to have an overview of all tracks. Now, a second thing to point out is that we actually have a repetition of records as a result of this query. So I have here all the entries for the HALOS 2011 track 2, and remember that track 1 was a grep sample, which is why it isn't in the result of this query, which is exactly what we want. But we have 5 entries for track 2, and indeed we wanted to see the total number of clicks, and of course the information is implicitly there, but actually what we set out to do in the beginning is to create an overview in which every transact is listed once, and we actually have a sum of all the clicks that have been collected in that field. So these are 2 problems that we will now deal with. Okay, so let's first deal with the missing tracks, and this problem relates to a bit of theory when it comes to relational databases, which is about join types. And join types are actually definitions of a relationship and the way that ties 2 tables together. Just very quickly, as an explanation of what that means. So if I double click on the relationship in the query design, we can see the join types displayed here in the radio buttons 1, 2, and 3. So the join types in SQL language are known as an inner join type or a left or right outer join type. Now, there's also another join type which is not relevant here, but just very quickly to point to this issue is that the basic relationship here is an inner join type. So that's always the default, and the inner join means that if you create a query based on 2 tables, you will get records that have a key in both tables. So you will only have tracks if there are records related to the tracking results, and you will only have results if there are tracks, if there are records related to those results in the table tracks. Now you may want to have either one of the opposite situations. So you may want to have in your resulting record set also tracks included if there are no corresponding records in results. And another way to say it is we want to have all tracks, no matter whether there are related records in the table results. And of course you can have that the other way around, so you can have all records from results regardless of whether there are corresponding records in tracks. Now, these 2 last variants are called left or right outer join, and left and right refers to the position of these tables in the SQL syntax, which is of course a bit obscure, and therefore in Access you can see here in the join properties window in text completely written out what I just said. So the first is the inner join include rows where the joined fields from both tables are equal, and then we have 2 options, namely second option is include all records from tracks and only those records from results where those joined fields are equal, and then the third option is exactly the other way around. And another way to look at this is to think in terms of a Venn diagram in which the inner join, these are 2 circles that partly overlap, and in the first for the first option you have an inner join, so you get only the overlap, and in the other 2 options you get a full circle left or right in the Venn diagram and the overlap as well. So just look this up if this is still now abacadabra to you, but it's part of database theory. So I leave it to this, and I will only explain this and how you can manipulate this for a query and what the effects are. And now to solve this issue, so what did we say? We did not have some tracts in our overview because there were no corresponding results in the table results. So what we need is we want to have an outer join, and actually we can simply read the text and see if that satisfies our wish in this case, and then indeed we can see that the second option includes all records from tracts and only those records from results where the joined fields are equal. So if we select that, if we click OK, and now you can see that the line representing this relationship now actually has a very clear arrow sign here at the right, pointing towards the results table, and this now actually represents this join type, saying that we want to have everything from tracts and only the results if applicable. Now let's check out the end result of this manipulation. If we click on view, we can see that indeed we now have all tracts from starting with 11 up to 20. And indeed we have no results from them, but nevertheless they are incorporated in our query result. And then the final remark to make here is that the join type that we now set is only valid for this query. So there's nothing in the relationship in the design window that has been altered. And in case you would create another query based on the relationship between these two tables, the join type would be the default inner join. Okay, so as for the second problem, we have to deal with that repetition of records. Now this is not a problem per se, but it's not resulting in the overview that we would like. And if in order to have a clear overview, we would like to see the total number of clicks per tract. And we can achieve this by defining an aggregate query. And aggregation here means that you add up records so you can perform a calculation or on one or more of the resulting record set fields. So let's go and find out how to do that. Okay, so the aggregate query is created by using this tool in the design tab of the query design raster. And if we click on the totals button, we can see that something happens, namely that we have another option here, which is total. And in the total field in the design raster, we now see appear this term group by. Now, what does this mean? As you may guess, this means that whenever possible, fields with identical values are grouped in a single record. Now, if we then click the total cell of the clicks field, we can then see that there is actually a number of options here. Now, if we would now select the sum option and inspect the result, we can see that what it does is indeed all the records with the same values, which are of course the location and the sample type, and the recorded by values are of course for every individual track number all the same. So based on that group by selection criterion, these records are now all aggregated. The only thing that was different from all these records in the data set that we viewed in the record set as a result of the query that we had before, the only thing that was different was of course the number of clicks. But here we said that we do not want to group by on individual number of clicks, but we actually want to sum the information in the fields that are related to these records that have all been grouped by based on the information in the other fields. So it sounds maybe a bit complex if you explain it, but actually it's quite simple. We now have an aggregation, so the set of records is thinned down by creating unique records based on all the criteria except the clicks. the clicks, we just made a sum of all the values in the fields that relate to those individual unique records. Now, going back to the design raster, as you saw, there are many options here that you can use. So all these functions can be used. So we can have the sum of all the values of the aggregated records. We can have the average. We can have the minimum, maximum, the count, so the actual number of records itself, standard deviation, variance, first and last. And then finally, we have two options, which are expression and where, and those can be used for more intricate calculations and criteria. For example, when you want to compare values of two different fields. Okay, now just to demonstrate then another way we can use these aggregation criteria, I will just now make a query based on the tracks table. I can remove the results table by clicking on the table and then hit delete on the keyboard. I am fine still with the way this is defined now. I just want to count the number of tracts that have been surveyed actually. So I just would want to remove and I want to order it by location, let's say. So I want to see how many tracts we have surveyed in what location. So and I'm fine with the transact criterion here. So what I could do now is I could just add the track number, but instead of group by here, I just select count. And then let's check the results. And indeed, what we can now see is we now have two records, because it has been grouping on sample type, which for all is transact. So the only actual variability is between these two locations, and then it created these two records with unique values and counted the number of tracts. And then just to point out the obvious, always make sure that you are aware of the difference between sum and count, because if you would use count in the query that we just created before with the clicks, you would just have the number of records counted and not a total count of the clicks, which is maybe something that is easy to think if you are not paying too much attention. Okay, so this is about aggregation queries so far. Now, as a final step in explaining queries and criteria that you can use, is I want to show you how you can use expressions, basic expressions, because actually so far we've been only working with a simple so-called where criterion. So this is actually a criterion that in SQL language equals select the all records that where the content of the sample type record is transact. But we can do a bit more complex expressions. So let's go back to the query that we just created, and I believe I have to make it again because I didn't save it, so I will do that very quickly. So what we had was the results, and I want to go back to the group by, and then I have clicks in this record, in this query, and I think this is, now I have, of course I should then go for the sum, and then we have what we had before indeed. Okay, so this is fine. I just do not have the join type defined, but that's not really relevant for what we are going to do now. So suppose we are, let's say, interested in all tracks that contain more than 50 clicks of all the combined results. So in order to get the selection on 50 clicks or more, we will use a comparison operator. Now, in the criteria raster cell of the clicks field, what we can now do is we can actually enter the greater than mathematical symbol. And if we now look at the result, we can see that we indeed made a subselection based on this mathematical operator. So we now have only records with 50 clicks or more, or actually in this case more than 50 clicks. Now, and as variations to this operator, you can do things like greater than or equal, and then you would have indeed 50 or larger. You can enter something like not equal to, so then you would get every result as long as the summed clicks are not 50, etc., etc. So you can use these basic operators to use to create subselections with more complex criteria. Now, in addition to this, you can also work with the so-called logical operators, and logical operators would in this case be the terms and, or, and not, which means and is both criteria must be met, or is one of the criteria must be met, and not would be the criteria must not be met. So just to explain this this principle, in the query design raster, we now have these two criteria entered on the same line, and this actually is translated into a query, an SQL, as an AND statement. So what we are asking is we want to have a record set as a result of this query that respects sample type field being transect and the clicks field containing more than 50 clicks. Now, if we would place the greater than 50 on a line lower, and you can see that you have here the or option, then the criterion now is interpreted as an or statement. So what it would now read is, give me all the records that have that let's say qualify by having the term transect in the field sample type, or are qualified because they have more than 50 clicks in the results in the clicks the column of the results table. And if I now check the result, we can see that we incorporated actually all the results from the group by query, and that is of course an outcome that we would have expected, because all records now only have to be valid for one of the statements. So the record will be incorporated if it complies with transect in the sample type column, but also if that is not the case, but we will have the sum of clicks greater than 50. So it will always comply with either one of these statements. Now, clearly, this specific example doesn't make any sense. I just included it to point out the principle. But what we can also do, and what I also want to show, is that you can create these or statements for a single field. So if I would, for example, have all the records selected that were recorded by a person with the initials AK, or I want to have all the records that are collected by a person with the initials VS, then I will have this as a result. So now actually I applied the OR statement, the logical operator, on a single field. And another way we could do this is to actually enter the statement in the same as part of the same criterion. So this means exactly the same as what we just did before, and we will have the same outcome. Now there are many more operators and functions that you could use as selection criterion, or even to have the query create new fields with values based on mathematical operations or one or more columns. But such queries fall outside the scope of this course. But for those interested to explore the possibilities, right-click in the criteria, a raster cell of a field, and select build. So you can go for this option, and then you get into the expression builder dialog window, and here you can select and construct complex statements using a wide range of built-in functions and features. Now, to complete this part, I want to point out the existence of two more useful operators. The first one is, for example, the between and construct. So if I would remove this criterion and I would go to the clicks again, let's say that I want to have a criterion for selecting all tracks with clicks between 100 and 200. When I would use the mathematical operators, I would have to enter a statement such as this. So greater or equals 100, and so I also wanted to comply with this statement, so smaller or equal 200. So this would now give me all the records with the result that is between 100 and 200, but it's a bit complicated to write. So what we also could simply have done is to write down between 100 and 200, and then we would have had exactly the same result. And then the final operator that I want to deal with now is the null and is not null operator. And in order to demonstrate the value of this, I will create a new query. Let's do that. Go to the query design. I just want to have the results here. And let's say we want to have the initials, we want to have the clicks and the finds, and I want to see all the results, but only if there have been actually any clicks. So I can just enter here is not null. It will be automatically changed to all caps, or at least the first character is caps. And if I then click on the query results, we can see that we have no fields or no records in which no clicks have been registered. And if I would remove, for the sake of demonstration, that term, we can see that we have records with 0 values. So this is a way that we can use null or is not null to further refine our outcome. And just note that a0 is a value entered into this field. So null is not the same as 0. And if you ask for not null, you will still be getting records with a 0 entered. Okay, so now I want to make things a little bit more complex in terms of query types. So far we've only been selecting data from our tables, but it is also possible to actually manipulate database and tables using queries. There are 5 different types of such queries in Microsoft Access. And actually they're all listed here in this box in the ribbon in the design tab. And the first that we use is the select, and the other here are the make table query, the append query, the update query, the crosstab query, and the delete query. And I will shortly explain these query types and give an example of 2 of them, which are the most frequently used, so the delete query and the update query. Okay, so let's first deal with an update query. With an update query, it is possible to update field values with new values in one effort. And of course, you can use the find and replace functionality that I've been showing in the first screencast, But using an update query allows you to use all kinds of criteria to determine which records need to be updated. So for example, suppose that the person with the initials AK did, as a result of a misunderstanding, maybe use the wrong term to indicate his or her sample type. So let's say it should have been grep instead of transact. Now let's create a query based on the tracks table. So I'll remove this, double click tracks. Oh. Now let's go to the query design and then add tracks to the raster, which is what I was planning to do. And let's enter the fields that we need for this query. So let's go to the recorded by and the sample type. And now we will click on the update query type here in the ribbon. So let's do that. Now we can see that the query design raster changes. So we now have here the update to field that appeared. Now what we want to do is we want to still add this criterion. So we want to add the criterion of AK. And then what we want to do, the update, we want to update the sample type column for the person with the initials AK to the grep sample. Now, if we would now hit this red exclamation mark, it would run the action, the query, and the values will be changed. And this is something that again cannot be undone in any simple way. So apart from making backups, etc., it is good practice to use the view option before you run this query and see if the result is what you would expect. So it will now show us what values will actually be changed. Now, I'm quite sure that this is okay. We entered the criterion AK. We want to change it to grep. So let's go for it and just run. Now we are about to update 10 rows, which sounds right because AK has been recording 10 rows. So if I click yes, then inspect the results, we can see that indeed now all the records that contain AK in the recorded by field have now changed into grep sample types. Now let's head on to another query type. Let's go for a delete query. So with a delete query, you can, as you may have guessed, delete records from your database. So let's go for it and select delete. And well, suppose we found out that the grep samples were all surveyed in the wrong way and should be redone. And let's say we need to delete all the records saying grep from our database. Now, we only want to have, in order to do this, the field sample type in our query design raster. Note that when I clicked on the delete query type, then the update to changed into delete. And this is actually, we can here enter two criteria, and where and from, and where is the default operator. So what this refers to is the criterion we enter into the criteria field. So if we now enter grep into this criterion field, what we now defined is that we want to delete from the tracks table all the records where in the sample type column the value grep is listed. Again, of course, inspect the results, see if your selection criteria actually works, because this is something that if you delete these records, they are gone. Now I can do this, of course, with this training database. So I will click on run. I will say yes, and it will warn us now. First of all, it told us we are going to delete records from our table, but it also tells us that we cannot delete 3 records in the delete query due to key violations, which of course has to do with the referential integrity, and that we do not allow for a cascading delete, which we've been dealing with in the second screencast. So it's fine. I will just accept that. Let's look at the tracks table. We can see that we indeed have now almost all the grep samples deleted from the table, except for these records over here with tract ID 9, 10, and 1. And that is because in the results table we actually have finds connected to these grep samples, and so therefore they have not been deleted. Okay, so let's continue a little bit with the other query types that we have. So we, as I said, we have the append query and the make table query. Now the append query you will use if you have two tables of roughly the same with roughly the same data, and you actually want to turn them into a single table. So what it literally does, it will append, so it will add the records from one table to another table. So let's just, for the sake of a theoretical example here, say that I have the tracks and the results from a campaign in 2015, and then I have from the campaign in 2016 a database, and I have again a tracks and results table. I import those two tables in this database because I actually want to combine the data, and then I would have, for example, results 2015 and track 2015, and then results in 2016 and track 2000, etc. And then I would use an append query to create to combine, to actually merge these tables. And on the other hand, we have the make table query, and that is simply a query in which you make a new table of the results. So remember that I said that a query is nothing but a definition with a selection, or, well, as you now learned, a delete action or an update or whatever. But that this is not a new table. The data is not copied. It's not stored in this new data set, or there's no new table. A make table query is what you use if you want to have that data to be stored in a new table. Okay, so the final query type that I want to address then is the Crosstab query, and I will make an example. I will do an example of this because it is a very powerful query type. So suppose that that we want to know what type of sample. No, let's say that we want to know what person collected the most finds, or the total number of finds. Let's keep it at that level, in using what sample type. So what we now actually want to do is information that is listed in as field values in a column. We actually want to transpose them and use them as column headers, so we can actually make what is a cross table effectively, and see how data intersects in a different way. So this question now does not necessarily make much sense, but I just will use this to demonstrate the principle. So let's create a new query. Go to the query design. I will enter both tables, and I will turn this into a Crosstab table. Now you can see that there's a familiar view here with the options. It's just that Crosstab has been added to the set of options, in which you can define how you want your Crosstab to be configured. And it's standard, by default, it's a total query, because somehow field values will have to be aggregated. So I will show you how you can do this. So let's say that I will have the recorded by. I want to have the sample type again, and then I want to have the number of finds. So what did I want to do again? I want to see per person. So I will have a row heading. I will make the persons into the row headings, and I will make the sample type into the column heading. So I'm going to transpose the two sample types that we have and make them into two different columns. And then on the crossroads between these sample types and the persons recording this data, we have the finds, and of course these finds we'll just display them as a value, so they're not going to be column headings or row headings but values, and then we have to sum them in order to get a total value for every intersection of sample type and person. So let's go to the view, and now you can see what I meant. So now we have here in this cross table, we have the initials of the people working in the area as row headers, and the values that have been entered into the sample time have been transposed to be column headers. So we now have these two values, grep and transect, and the finds that have been collected by the person with the initials AK as grep samples are summed in sum 149, and there have been no transect finds collected by this person, and then you have the next person, and so on and so forth. So you can imagine that this is a very powerful tool to create very useful overviews of data that you have. Yeah, so in with this example of the Crosstab query, I've come to the end of this introduction on creating queries. There's just one more remark that I want to make, and in order to demonstrate this, I want to go back to a simpler query. So let's see, we did save this query, which was simple. Let's keep this as a sum. So now we have again these records that are grouped. There's the criterion here is transect, and we sum all the clicks. And what I want to point out is that we have this definition here graphically, but what we can do is if we go to view and we click on the SQL view, what we then get is how this query actually looks in SQL, so the structured query language. And it looks complicated, but it really is not that complicated, taking into consideration everything that I have been explaining. So you see this is a select query, then you have here a whole range of fields that are selected. So from the table tracts we have the field recorded by, and then comma, from the table tracts we have the field location, and so on and so forth. From the field clicks we have the sum, and then we take that data from these two tables that are combined with an inner join. They are grouped by, and then again a summation of the fields that it has been grouped on or aggregated on. And finally here we have a sample type transect as the criterion. So it looks complicated, and maybe it is in this example more complicated than necessary. If I would have a simple selection query, and let's do that for the sake of simplicity. So let's say that I would just have a query based on a single table. So we now just have all the transect samples from the tracked table, and if I would now go to SQL view, we have a much simpler definition. So here we have, again, we start with select because it's a selection query. We have the field recorded by from the table tracts, the field location from the table tracts, sample type and track number from the table tracts. It says here explicitly select these fields from tracts where, and then again we have this criterion enter tract sample type is transect. So If you want to learn or understand a bit how SQL works, it is very easy to see how your query actually is written in SQL. And if for some reason you find it easy to, or you know SQL and you want to go from SQL to Access, know that you can enter this, you can change this syntax here, and if you would then go to the design view, your query would be updated based on the SQL that you have been coding in the syntax environment. So yeah, this is the final thing that I really wanted to show on the query side of Access. And so with this, we've come to the finish of this third screencast, and I want to thank you for watching and listening.